Okay, 4.4 exponential and logarithmic equations. So now we're going to kind of use everything we've learned in the previous couple sections, and we're going to put these into equations, and we're actually going to be solving for values now. And so the first property we're going to look at is the one-to-one property. So one-to-one property, and basically what that means is if you can have your bases be the same, okay, so if we can have the bases the same, now they have to be greater than 0 and not equal to 1. But if we have identical bases that fall into that category, then what we can do is we can basically just set the exponents equal to each other. So you just take the powers and set them equal to each other. So what we have to do is make the bases the same in order to use this property. Now, some other properties that will be useful is some of our exponent rules. And so our power rule right here, if you have a power to a power, you actually multiply those two pieces together right there. And if we have a negative exponent, then you have to take the reciprocal in order to make it positive. So let's go ahead. Let's look at this. So solve each exponential equation by expressing each side as a power of the same base, and then equating the exponents. So you might be able to do this one in your head. You could probably look at this and say 5 to what power equals 125, and you could probably guess that it's going to be 3, and that is true. But they're going to get a little bit more complicated as we go on. So I really want to use that one-to-one property for when it gets a little bit more challenging. So what I'm going to do here is I have 5 to the power of x, and then 125, that's the same thing as 5 to the power of 3, right? 5 times 5 times 5. And so then what I can do is I cancel out those common bases, and then I just get x equals 3. And there we are. So looking at example B, it's very similar to what we just did here. It's going to be a little bit more challenging because this time it would be maybe, you could maybe guess what, X would be to give you 32, but it'd be a little bit more challenging. And so once again, what we want to do here is we want to get those common bases so we can cancel them out. And so 32, you might not know, it's going to be 2 to some power, right? And you might be unsure, right? What would 2 to what power gives me 32? So you can actually just start multiplying 2 together. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Well, how many times did I have to do that? Well, let's see. 1, 2, 3, 4, 5. It took me multiplying 2 together 5 times. And so over here, I'm going to change this 32 into 2 to the power of 5. And then now we have that common base that we're just going to cancel out and set the exponents equal to each other and then just solve this. So let's see, we're going to go ahead and add 1 to both sides. So then we're going to get 2x equals 6. And then we'll go ahead and divide by 2 on both sides. And we're going to get x equals 3. Okay, so those first two were not too bad. Now let's look at C. Well, interesting. See, how am I gonna manipulate 27 into a 9? Hmm. Well, 9 to what power would give me 27? That, not that it doesn't exist, but that does not sound like fun. And so what are we going to do here? Well, what we're going to do here is we're actually going to adjust both of them because I can adjust both of these into base 3. So the 9, I'm going to put that as 3 squared, and then we'll raise that to a power of x. And then 27, we'll put that as 3 to the power of 3 right there. And so let's see. Um, so then I have to use my power rule. Before I try to cancel out, cancel out the common bases, I have to do the power rule. And the power rule is I multiply power to a power. So this is going to become 3 to the power of 2x, and then equals 3 to the power of 3. And then now I can go ahead and remove those bases and just set the exponents equal to each other. And then we'll go ahead and divide by 2. And we're going to get x equals 3 halves. Okay, so D is very similar. So I kind of encourage you maybe to pause the video and go ahead and try this on your own. But I'm going to go ahead and continue. So I have base 8 and base 16. And so common base I can come up with is going to be 2. So 8 is going to be the same thing as 2 to the power of 3. And then I have this other power right here, x plus 3, which is going to go right there. And then equals 2 to the power of 4, and then raised to the power of x minus 1. Now, once again, before I can cancel out the common bases, I have to complete the power rule. Now, you have to be careful with the power rule because you multiply them together, and a common mistake is students only multiply the x by 3. But that power of 3 right here has to get multiplied to the x plus 3. So I'm going to end up with 2 to the power of 3x plus 9. So you have to have that plus 9 there. You have to distribute it to that value also. Same thing on the second one. This is going to become 2 to the power of 4x minus 4. And now we're ready to cancel out or basically remove those common bases and just focus on the exponents. So 3x plus 9 equals 4x minus 4. And I'm going to subtract 3x from both sides just to keep my x positive. So then we're going to have 9 equals x minus 4. And then we'll add a 4 to both sides. And we end up with 13. So x equals 13. So that's the value that if I were to plug it in, then the two sides would be equal. Okay, moving on. And so now we're going to look at some logarithm equations here. And so it says using logarithms to solve exponential equations. So step one, isolate the exponential expression. So if you look at my first three, they're all isolated. If you look down below here, E is isolated, my base is isolated, but here you can see on D that that 5 is not part of the base. And so that would be something that would need to get fixed up. That's part of step one, isolate the exponential expression. Step two, note the base of the original exponential equation and then take the log on both sides using that base. Okay, so this can be something new that y'all haven't seen before. And so we'll do that in just a second. And then it says use the change of base formula to solve for the variable. So what we're going to do here is one of our properties of equality, basically, that they're saying here, if you, on number 2, let's just say we have A equals B or whatever. Well, that would be the same thing as if you were to take log of A is equal to log of B. So that's basically what they're saying. You can take the log and you can do whatever base you want. And so on this first example, example A, I have base 10. So I'm going to take log base 10 of both sides. So it's understood. So I don't have to write it actually. So go ahead and just leave it like that. So log of 10 to the power of x is equal to log of 8. And so then another one of our properties is that if your log base matches what you're evaluating, then it's going to simplify into whatever that exponent is right there. So this right here, I can go ahead and reduce this just down to x right here because my base matched. So I hadn't understood base 10. And so if the bases match, it's just going to be, it can simplify into what the exponent is, which in this case is x. So we end up with x equals log of 8. And so when you're doing your homework, you're going to have to put your answer in as an exact answer, which would be right here, log of 8. And then your rounded answer, let's see, we're going to round 3 decimal places. And so let me go ahead and get my calculator out so we can do that. And so let's see, log of 8. And so my calculator has understood base 10 in there. And so let's see, that's going to be 0.903. And so those are my two solutions. And so they're going to be asking you for both of those. Okay, looking at example B, my base is E. So that's a good thing because what I'm going to do is I'm going to take the natural log of both sides and so then I'll have a match on the left side. My base matches what I'm evaluating, and so it's just going to simplify into the power, which in this case is just x again. So x equals the natural log of 13. That's my exact answer. And then we'll get our rounded answer. Let's see. So this time I'm going to have to do natural log. So let's see, we're going to do natural log of 13. And let's see, what do we get? We get 2.56. Now that 4 is going to have to round up to a 5 right there because of the 9 in my fourth spot right there is going to round that 4 to a 5. So 2.565. Okay, so far so good. Now example C, we've got that base 6 there, and so that will make things a little interesting here. But and you might, if you watch the videos on the homework, they may do it slightly different. But to me, I think the easiest thing to do here is to take log base 6 of both sides, so I can continue to use that property we've been using where that will reduce down to the exponent. So then I have to take log base 6 of 28 right here. And so what will happen here is this will reduce down to the power, and then I'm left with log base 6 of 28. Now, depending on what calculator you're using, your calculator, you may be able to input that. But most of the calculators that we work with, you have to use the change of base formula. And I believe on your homework, that's how they're going to want you to put in your exact answer. So what we're going to do here is you can either use log or natural log. It doesn't really matter. I'll use natural log. So natural log of 28 divided by the natural log of 6. So that's using the change of base formula right there. So that's my exact answer. And then we'll go ahead and put it in the calculator to get our rounded answer. So here we are. So let's see, I have to do the natural log of 28, close my parentheses, divided by the natural log of 6, close my parentheses. And let's see, so I'm going to get, this rounding here is going to be kind of interesting. Let me Okay, so I grabbed a little snippet of this so that I can kind of show you on the rounding here, because what's going to happen is this 7's going to round the 9 up to basically kind of like a 10 to where it's going to carry over a place. And so I'm actually going to end up with 1.8, and then that 9 rounding up to a 10 is going to round that 5 to a 6, and then I'm going to have a 0 right there. So it kind of basically rounds it to a 10 that you add right here, and the nine kind of goes away, right? And so then that rounds the 5 to a 6, and then I have a 0 in my thousandths spot. And so that is my answer for that. Okay. Now, example D is going to have that first step that we haven't seen yet, where I have to isolate the base. And so the 5 is not part of what's being raised to the power of x. So I have to start by dividing both sides by 5. No big deal. So let's see, we're going to get 4 to the power of x um, equals 78 over 5. Okay. And so then now what I'm going to do is I'm going to take log base 4 of both sides. So I'm going to have log base 4 of 4 to the power of x equals log base 4 of 78 over 5. And then this is pretty much just going to be like what we did on the previous one here. So this will reduce down to just the x, the power. And then I'm going to have to write this using change of base. So it's going to be the natural log of 78 over 5 divided by the natural log of 4. And that would be my exact answer. And then we'll get our rounded answer by putting it in the calculator. So let me grab my calculator. So clear it out. So let's see, we're going to do natural log of 78 divided by 5, close it, then divided by the natural log of 4. And then we'll press enter. And so we're going to get, let's see, this one's going to round to 1.98, and then that needs to round to a 2. So 1.982. So there are my two answers, my exact and my rounded answer. Okay, on the next one, you can see that we have a base E. And so what we'll do here is we're going to take the natural log of both sides. So the natural log here and the natural log here of 32.6. And so once again, my base matches what I'm evaluating. So I'm going to cancel that out to simplify into my exponent, which is negative 3x. Then equals the natural log of 32.6. And then now what I need to do is to solve for x, I'm going to have to divide both sides by negative 3. And that is actually going to be my exact answer. So my exact answer is the natural log of 32.6 all divided by negative 3. And then now we'll go ahead and put this in the calculator to get our estimate. So here we go. So we're going to do natural log of 32.6 divided by negative 3. Make sure you put in you use the negative key, not the minus key, because you'll get an error. And so let's see, we get negative 1.161. Negative 1.161. Okay, so this time I didn't round that up because the number following my third decimal place was less than 5. All right, so we got 2 left here. And so F, kind of similar to the one we just did, but I have to, kind of like number 5, I'm going to have to start by dividing both, sorry, like example D, I'm going to have to divide both sides by 5 to get going. So that's what we'll do here. So we'll divide by 5 here and here. So that cancels out. So we've got e to the power of 2x equals 6 over 5. Then we'll go ahead and take the natural log of both sides. And so then what we can do here is reduce this down to its power, which would be 2x equals the natural log of 6 over 5. And then next we'll divide both sides by 2. And then this will be our exact answer. So x equals natural log of 6 over 5, all divided by 2. So very similar to what we put in last time. So here we go, natural log of 6 divided by 5, and then divided by 2. And it's important that we close that parentheses, right? And so we'll press enter. And so this time, let's see, we get 0.091. 0.091. And there we go. Okay, last one of this type here. And so we have that base 5. And so I'm going to take log base 5 of both sides. And this one's going to get a little interesting. The hardest part's probably going to be putting it in the calculator properly for when it comes time to get our estimate. Okay, So now that I have that log base 5 on the left side, I can cancel this out, and I'm left with 3x plus 2 equals, and then if we want to, we can go ahead and transform this into the change of base form because we're going to have to do that anyways. So log of 166 over, or well, we can do log or natural log. I've been using natural log. I think I'll continue to use natural log. But yeah, it doesn't matter. You can either use log or natural log as long as the bases match. So here we go. And then now we just need to solve for x. So what I'm going to start off by doing is subtracting 2 from both sides. Okay. So then that's going to leave me with 3x equals the natural log of 166 divided by the natural log of 5 minus 2. On this last step, there's a couple things we could do here. We could divide everything by 3, which is fine. If you're going to do that, so if you divide by 3, you just want to make sure the numerator is in parentheses, just because when you put it in the calculator, it might misinterpret it. So you just kind of have to be careful about that. Um, and that's fine. You can leave it like that, but I'm going to show you a couple different ways you could have done this. You could have also multiplied both sides by a third. And you could have literally just kind of put 1/3 on the outside, and you could have had natural log of 166 over natural log of 5 minus 2. And you could have it like that. That's sometimes a popular way of doing it. So instead of dividing the whole thing by 3, you can just multiply by a third. So either one is fine. You could even distribute the 1/3 if you want, but I would go with one of these two probably. And so this is where I said it kind of gets a little tricky when we put it in the calculator. And so you can put it in either way. You just want to make sure you have those parentheses. And so if I do put in the 1/3, um, what I would probably do is I'd want to put that 1/3 in parentheses just to be safe. I don't think it wouldn't actually matter in this case, but just kind of want to be careful. And then open parentheses, let's see, we're going to have natural log of 166 divided by natural log of 5. Close that parentheses. You want to make sure you close it. And then I'm going to subtract 2. I have to do minus 2. And then close that parentheses that I originally opened when I began the natural log part of it. So I'm going to go ahead and press enter. And I'm going to go ahead and include a little snippet of this so we can see this in the notes. So let me go ahead and paste that. So there we are. And so rounded, this is going to be, x is going to be approximately 0.392. So that's our approximation right there. This is our exact answer right there. Okay, so that's going to conclude part 1, and we'll start part 2.